Okay, here's our Unit 8B Lesson 5 note, line of best fit. So after this lesson, we're going to be able to create a line of best fit using technology. I can draw conclusions about data represented in scatter plot using a line of best fit. So, A, line of best fit is a line that most closely follows a trend in data. Okay, to model data using a line of best fit, make a scatter plot. Okay, and today we're going to do them by hand, but then we're going to show you again how to do the line of best fit with technology, but we'll do a couple by hand. Then we're going to decide whether the data can be modeled by a line. So positive correlation, negative correlation, we can model that by a line. No correlation, we can't do that. Then we're going to draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. So we're going to talk about this, do an example. Then we're going to be able to write an equation using 2 points on the line. So we're going to write an equation using 2 points. We've done that before. We're going to use point slope form. So example 1, the table shows the number of active red-headed woodpecker clusters in a part of DeSoto National Forest in Mississippi. Write an equation that models the number of active clusters as a function of the number of years since 1990. This is my X. This is my Y. Create a scatter plot. So we have to label those axes. So my X's are going to be the years, and these are going to be the active clusters. Okay, they already got numbers on there, so now we got to plot this. 222, approximately right there. 324, right about there. 427, 527, 634, 740, 842, 945, and 10 is going to be 51, so just above there. Okay, hopefully you guys can see those points. Okay, so those are our points there. And now we're going to draw a line of best fit through the data. As a guide, try and have as many points above the data, points of data fall above the line as below. So we want to put a line here like this. This pencil's awful thick, but we want to create a line where it has as many points above as below. So we need to use a ruler. Okay? And I'm going to look maybe, we want to definitely get it through 2 points. I was looking at maybe looking at this point and this point. So if I draw a line like that, so I drew a line that definitely went through this point and definitely this point. Okay, we got maybe this point's below, about 2 points above. So that looks like a line of best fit. Okay, that's what we did here. Now we're going to write an equation for your line in slope-intercept form. So I'm going to take this point right here. Let's see, maybe I went through this point here. So this point was 6 and 34. So 634. And I'm going to use this point 9 and 45. I think it definitely went through. So 9 and 45. Okay, now I'm going to find the slope. So m equals y2, 45 minus 34 over 9 minus 6. So it's 11 over 3. So that's my slope. Now I'm going to use y minus, I'm going to use this point right here, 34 equals 11 over 3 times x minus 6. Y minus y1 equals m times x minus x1. That's what I plugged it into, point slope form. But I want it in a new slope intercept form. So now I have to distribute. So I'm going to go up here. I'm going to say this is y minus 34 equals 11/3 x minus 11/3 times, this is going to be 22 when we put it in the calculator. So 66 over 3 is 22, so negative 22. Add the 34 to both sides. I get y equals 11 over 3x plus 12. So that's my line. That's my equation of the line. Okay? And it's not exact because we're going to get it exact when we use technology, but this line of best fit through those points there, maybe this point would have made it come down a little bit more. Maybe it should have been down here. But that's our line equation. And now it says use your linear function to predict the population in 2008. So, if this was years since 1990, so 2008 minus 1990, that's going to be 18 years. So, if I was in 1992, I'd minus that, I'd get 2 years, that's where I'd be here. If I plug 2 in, I should get 22 out of our equation. Okay? Not going to be exact. So, I'm looking for the population in 2008. I want to predict it because this only goes up to 2000. So, 18 years. So I say y equals 11/3 times 18 plus 12. So 11/3 times 18 in the calculator, we're going to get 66 plus 12. So approximately 78 active clusters in 2008. Okay? And that's how we do it. Whoops. So we got to figure out 2008. Well, from 1990, I subtracted, I get 18. I plug 18 into my equation, and I get that there's going to be 78. So it's going to linear. It's a linear function. It grows like that. Keeps going out. Okay. Example 2. Same thing. We're going to create a scatter plot. This is a biologist is studying the relationship between a tree's diameter and its height. So I'm going to say this is my x, this is my y. So diameter in inches, and this is the height in feet. So I'll plot my points. Here's 2, 8, 3, 10, 4, 16, 5, 17, which would be in the middle, 6 and 22, 7 and 20, and 8 and 29. So 8 and 29. So it looks like I didn't grow in that year. So I need to draw my line of best fit. And then maybe, let's see. I kind of like to see how many points I can get. I have about 2 points below it. There's about 3 above. So sometimes you can't get an exact, but I think this is probably the closest we're going to do. There's 2 points below, 3 above. Looks like a pretty close line. Now we're going to write an equation. I use this point and this point, definitely it went through. So this point is 2, 8. this point here is 517. So for you tries, you try the rest. I want you to write the equation in slope-intercept form using these 2 points. Okay? Then we're going to use our linear function to predict to the nearest foot the height of a tree given its diameter is 14 inches. So what do I do there? I'm going to plug 14 in. So if the diameter was 14, what would the height be? Well, whatever equation I get here, I'm going to take 14 and plug it in down here. All right, we'll see you tomorrow.